this is Leon. I'm the team leader of the HelloCity AI. Tonight, I'm very excited to share with you the results we've achieved over the past 3 months. Next page. First, please allow me to introduce what HelloCity is. HelloCity is an AI-powered lending assistant designed for people relocating to new cities. The problem today is that newcomers face scattered information, language barriers, and confusing procedures when they first arrive. That creates stress and slows down their ability to settle in. So HelloCity solves this by combining conversational AI with structured plan and official resources. With just a simple chat, users receive personalized step-by-step guidance, making the first mile abroad clear and manageable. And then I will hand over to my team to go through the details to you guys.
At the beginning, our team was purely made up of developers. Recently, with the addition of DevOps, we've gained stronger infrastructure support, smoother deployments, and faster feedback loops. This has allowed us to focus more on building features while ensuring stability and scalability. Combined with our proactive communication and collaborative environment, our project is able to progress quickly and effectively.
A quick overview of our tech stack. On front end, we use Next.js 14 with TypeScript, Tailwind, MUI, and Storybook. Makes our interface smooth and easy to maintain. We use Redux, managing the application state, and Husky, and show clear commits. We also integrate the Vercel AI SDK to power AI-driven features. For backend, we run .NET 8 Web API with PostgreSQL and an Entity Framework, which keeps data stable and reliable. We use Python with Fast API, LangGraph, and Celery to handle AI workflows, and XUnit for testing. Authentication is handled by Auth0 with CWT, so users can log in safely. We also added Lingui, so the site can switch easily between 5 different languages. For CI/CD, we use Docker and GitHub Actions to automate testing and deployment. Finally, everything is deployed on AWS services like Amplify, EC2, ECR, Load 53, and S3 to make the system ready for production. In short, HelloCity shows how a small team can build a modern, secure, and global-ready application with the right tools.
Yeah, and here is the overview of the HelloCity. On the left, we have the client and front end built with Next.js and TypeScript. This is where users interact through web or mobile, and it also connects to Auth0 for registration and login. In the middle is the core business layer, powered by .NET 8 and Entity Framework. This layer manages authentication, database interaction, exposes APIs, and also communicates with our AI microservice. On the right, the AI microservice is written in Python. It builds prompts and calls the OpenAI API, then returns structured JSON results such as checklist or conversation replies. To make sure users receive these AI responses in real time without long blocking waits, the frontend also includes a lightweight polling mechanism. When a user triggers an AI task, for example, generating a checklist, the frontend periodically posts the API for task complete status. This ensures a smooth user experience even if the AI takes longer to respond, and also makes the system more robust against the timeouts or network interruption. At the bottom, we have the data layer with PostgreSQL, which stores user data, checklist, and chat sessions. We also integrate Amazon S3 for file storage. Beyond our own layer, several external services are critical. Auth0 for authentication, Amazon S3 for storage, and OpenAI for AI-powered responses. Together, this architecture makes HelloCity modular, scalable, and ready for future expansion. And with the architecture in place, let's now take a closer look at the user flow.
Next page, please. All right. We've designed a clear and intuitive user flow to ensure a smooth and supportive experience for every visitor to our HelloCity. Users begin their journey on the landing page, where they can receive a brief welcome, select their preferred language, and also have an overview of the unique value of our platform. After that, User can create an account with Auth0 and complete a short profile with personal details. These details allow our AI system to prepare a more personalized plan and a checklist that will later enhance the conversation experience with the chatbot. Once onboarding is complete, users can engage in interactive AI-powered conversations to receive the tailored guidance, automatically generate a personalized checklist, and manage their ongoing tasks with continuous support from our intelligent assistants. This flow ensures that users feel supported at every step, making it easy to plan, organize, and confidently navigate their new journey with HelloCity. Let's have a quick look at our live demo to bring you through this structured user flow. I will hand it over to you, Paul, if you are ready.
Okay, can you guys see the website? Can you guys see the...
Yes.
Yeah.
Yes, we
Yeah,
can see
it's
it.
all good.
Okay, so we have made some improvements on our landing page since the initial presentation. Thanks to Lingui, as described before, our website supports English, Mandarin, Korean, and Japanese localizations. If you observe the URLs, as I change the language, the URL also change with the corresponding option that I select. And then essentially for the hero page, we have a user testimonial and a more descriptive info page with the addition of a better responsiveness design. So when I shrink the page width here, we can see that our navbar has turned into a more responsive form, and it allows for user immersion and enables better flexibility of HelloCity across all mediums and countries. And then we'll demonstrate the login process through Auth0. So here we'll just sign in, and then we'll just continue with Google SSO. And then here is our chat page. So the login is successful, and then we can see the user profile that's on the bottom left corner of the tab here. And then we can further examine the user information in the profile page. So including a full workflow to update profile images that is stored on Amazon S3, as well as providing some context to your profile if it's missing. So here we'll just fill in University of Sydney and then our major. And then for the city, for the profile image, we can also change it to something else. I'll just select something, and I'll just do this, and then submit. And then as you can see, it's also changed on the bottom left corner. And then we will just go back to the chatbot page. And we may begin our AI journey simply by speaking to the chatbot. So in this case, we'll just describe the location that we're traveling to. So as an example, I'll do Sydney, Australia. And the chatbot will provide a response and also gather for extra information when it's suitable. So in this case, it's asking for the length of our stay and also when are we arriving at Sydney. So we'll simply just fill that in. And then the chatbot will provide us with a short recap. And then in this case, we just say yes in order to start the checklist generation flow. And then we have also implemented interval polling combined with chat streaming mode, and this generation status actually persists even when pages change. So here I'll go back into the main page, into another page, as you can see, and then we can go back to the chat page and select the conversation that we have just created. And as you can see, it's still there. The conversation keeps track of the generation process, presenting the plan with accuracy and risk-aware prudence. So As you can see, it has produced our checklist, and then we can view it in the checklist view. And then for our checklist, we have individual items that the users can view to their liking, as well as modify if they think the AI has some room for improvement. So we can actually edit the order of the checklist, as well as editing some of the plan item if we have other things in mind. Here we can modify all of the metadata, including the description and the importance, as well as the due dates and any categories that we like. So the modify is successful, and then we can use the checklist just simply by toggling the complete status and then putting it into a view that the user can look at when landing in a foreign country. And then a thing that we are trying to implement is to integrate GPT-5 with the checklist generation. However, selecting GPT-5 adds more granularity to the checklist content with more specific conversations. So as you can see here, the user's need is fulfilled more perfectly. However, the process takes too long, which is something that we seek to optimize in future development process. And then that's it for our demo. Let us return to the slides with the specific on our authentication process. Also, you can visit our website on hellocity.com. Yeah, that's just something that you can look at if you want to. And can you see the PPT?
Yeah, I could see it.
Okay.
All right. We use Auth0 for unified authentication in HelloCity. There are 3 reasons. First, we're offloading login and token insurance to a specialized service, which could reduce security risk. And the backend can use GWT barrier for standardized signature validation and authorization. And configuration could simple across environment and easy to operate. Our overall flow is when a user clicks login, he will be redirected to Auth0 to authenticate, then redirected back to our set. On the front end, our Redux Saga and root will reserve this information and automatically attach authorization barrier GWT to each request. The backend uses .NET GWT barrier to strictly validate the issuer and the audience, and to enforce role or scope-based access control. This design centralizes token management and authorization to the server and backend, keep the front-end simple and controllable, and work well across multiple languages and environments. Thank you.
Okay, I will quickly walk you through how HelloCity handles profile image uploads with Amazon S3. S3 buckets provides desirable features to keep our database clean, ensure secure and scalable image storage, reduce cost, and deliver fast, reliable access to user profile photos. When a user uploads their photo from the front end, the image is first sent to our backend API. The backend runs validation, check file type, size, and format before generating a unique file key for the image. That key is then used to upload the file securely into our S3 bucket. Once the upload succeeds, we save the S3 key directly into our user profile record in our database instead of storing the actual image. This design keeps storage scalable and secure while also making it easy to fetch images later. To display the image back to the user, our backend generates a pre-signed URL from the S3 key, which the front end can use to load the photo. These URLs are temporary, ensuring security while still allowing smooth user experience. In conclusion, our flow ensures the profile image is validated, securely stored in S3, linked to the user in the database, and also safely retrievable with a pre-signed URL.
Since we target users around the world, internationalization is one of our key focuses. We use Linked to achieve this. First, we configured the language with 5 locales, English as the default language, and additional support for simplified Chinese, traditional Chinese, Japanese, and Korean. More languages will be added in the future. We use the PO format for translation files and automatically extract translatable text from our React components. Next, our implementation supports both client-side and server-side rendering, ensuring that users get localized content no matter how the page is loaded. Then we build a custom React context, a language provider to manage language switching and URL routing in a consistent and scalable way. Finally, to make collaboration smoother, we developed a custom script that automatically resolves the merge conflicts in translation files, since multiple developers work on the same repository at the same time. We also use root-based language switching, so URLs like /en and /zhcn automatically set the correct language, and when a translation is missing, our fallback system gracefully defaults to English. In summary, our system offers type-safe translations with full TypeScript integration, is SEO-friendly thanks to proper language routing, and developer-friendly with automatic string extraction. The architecture is scalable, supporting future languages, and is production-ready, backed by comprehensive testing and automated conflict resolution. Thank you.
So in our backend, .NET serves as the stable core of the entire system. We use a classic 3-layer architecture, controller, service, and repository to keep our backend clean, testable, and scalable. The role of .NET is clearly defined. It handles authentication through Auth0, acts as SSE proxy for real-time chat streaming, and manages all data persistence through PostgreSQL. Importantly, it does not perform AI inferences. That part is handled by our Python microservice. So .NET focuses purely on security, stability, and performance. Inside this layer, we also integrate cross-cutting tools like Serialog for structured logging, Swagger for API documentation, and AWS S3 for cloud storage. All user requests, whether for user conversation, checklist, or chat proxy endpoints, pass through this pipeline, ensuring consistency and reliability across the system. In short, .NET is our backbone. It keeps the system authenticated, connected, and persistent with delegating AI tasks to specialized services.
Now let's take a look at our data structure design. Our system is centered around AI-driven task management model where users can chat with the AI to generate personalized relocation checklists and manage their tasks efficiently. We have 5 main entities: user, conversation, message, checklist, and checklist item. Users store authentication and personal information such as nationality, city, and preferred language. Conversations record AI chat sessions. Each user can have multiple conversations, and each conversation includes multiple messages. Messages contain the actual interactions between the user and the AI assistant, capturing both sides of the conversation. Checklists are generated from conversations. Each conversation can create one or more checklists, and each checklist contains several checklist items. To support updates and refinements, checklists are also versioned, meaning that we can update the checklist versions and modify its content. Checklist items represent specific user actions, such as booking a flight, updating personal info for visa, or applying for housing. We use PostgreSQL as our main database, with JSONB fields for complex structures like AI message parts and metadata. This gives us flexibility in handling dynamic AI-generated data while maintaining a clean relational structure. In short, our schema supports the entire workflow, from user input to AI understanding, to checklist generation and user task management, ensuring everything is organized, maintainable, and scalable.
Let's walk through how a checklist is generated in HelloCity. The process begins at the entry point after the user sends a message. That message goes through LangGraph orchestration, which manages the entire AI workflow, executing the chatbot. Then token response will string back through SSE in real time. The orchestration layer ensures our conversation feels interactive and dynamic. Once the system has gathered enough information from the user, the task trigger step activates. The chatbot agent invokes a tool and submits a Celery task for asynchronous background processing with the help of Redis. This lets heavier LLM computation happen without blocking the user experience. The system detects that more information is needed, for example, gathering links to government websites about a particular item, then a web search tool will automatically gather that additional context, maintaining accuracy and personalization of the checklist to the user situation. Finally, in the generation engine, Celery executes the LM on the structure output constraints and the pydantic schema validations. Using the enriched context, it generates a validated JSON checklist and save it. In the first iteration, the AI workflow followed a linear architecture where messages were sequentially passed through the chatbot, then a retriever agent, and then the web search agent before receiving a final decision node that determined whether to generate a relocation checklist. This pipeline operated deterministically with minimal feedback or adaptability between components. In version 2, the system evolved into a human-in-the-loop design, where the chatbot maintained an ongoing context-aware dialogue with the user instead of immediately invoking checklist generation. The model deferred this step until it inferred that sufficient contextual information has been gathered through conversation. So when generating the checklist, the agent will utilize string mode and output the most recent progress continuously to the user. In version 3, the workflow was further scaled and optimized by assigning distinct LMs to different agents based on the task complexity. Lightweight models like the 4.0 Mini manages fast conversational and retrieval tasks, while more capable models, in this case we can select the GPT-5, handles reasoning intense process like checklist synthesis and conversation summarization. This multi-model orchestration significantly improved both generation speed and overall system efficiency.
From an engineering standpoint, we've focused on building a robust and maintainable infrastructure, emphasizing speed, consistency, and reliability. We've created over 26 reusable UI components to ensure consistent design and a unified user experience across all products. We implemented structured logging across all services to provide a real-time system monitoring, error checking, and performance insights. This helps the team quickly identify and resolve issues throughout the development lifecycle. Our automated deployment pipeline ensures rapid, secure, and reliable releases. Each deployment includes automated testing and health checks, greatly improving release speed and stability. Together, these engineering practices make the HelloCity system AI-powered and production-ready, capable of supporting both rapid iterations and long-term scalability.
Okay, and I believe that marks the end of our presentation.